Hello friends and students. Here I am from again Shahan Virtual Academy, and my name is Engineer Shahan. So today's topic is the thermal expansion. Actually, this is the topic of the physics. So let's get started. Thank you. What is thermal expansion? When we just basically this word derives from thermal and expansion, means when we heat to the body, we just provide the heat to the body, so it expands. When we just give heat to the body, okay, let's suppose we have a rod, we just provide heat to the body. So what the process begins, basically when we give heat to the body, so the molecules, you should know about them, kinetic energy, the molecules get energized. Once the molecules becomes energized and mobile, so they start moving, and you should know about that. What is the status of the molecules of solids? Molecules of solids is so tightly packed, they are unable to move. But when you give the heat energy, it suddenly becomes to move and move here and there. So when they get the enough energy, so which is the kinetic energy. So because the energy created by creates in any body due to the change in motions, it is a kinetic energy. So same is produced in molecule of solids, and when they get the enough energy, they just hit the wall of the rod or at the end, so it becomes expanded. Okay, so this is basically the theory of thermal expansion. So the expansion found in the body of solids due to giving heat, that's called thermal expansion. Thermal means heat, and expansion means increase in length, whatever length or volume or area after giving heat. So this is called thermal expansion. Okay. Look, so there's three types of thermal expansion there. First one, linear thermal expansion. The second one is superficial thermal expansion. Okay, and the third one is cubicle thermal expansion. So here we will discuss the two main important, which is that and that in descriptive way, while we just give you the definition of all three. Okay, let's get started from the linear thermal expansion. It's simple. When we give heat energy to the solid, okay, when we give heat energy to the solid, and there's an increase in the body lengthwise. Okay, let's suppose this is the body. Okay, when we just heat it, so they increase lengthwise. So this is called linear thermal expansion. Okay, and same is superficial, and same is cubicle. When we heat to a body, okay, we just give the heat to the body, and they expand on heating area wise. This is the lengthwise, this is the area wise. So what is the area wise called? Superficial. And cubicle means volume wise. When if you just heat to the cube, okay, so they increase. Cubicle wise means volume wise, means this is the cubicle expansion. So here we go, and they're basically a relation of we just describe you about the linear thermal expansion, just giving you a little bit description. When we just give the heat, So let's suppose its initial temperature is T1 and the final temperature is T2. So change in temperature, which is delta T, T2 minus T1. So what is the basic theory? The basic theory is the change in temperature. When we maximize the change in temperature, so it change in length will be also maximized. Means we give the difference of temperature at 80 degree. We give 80 degree temperature to any body on the lengthwise. So it increase maximum way with respect to that temperature. Okay. So delta T is always directly proportional to delta L. Okay. Now this is the one, and delta. Okay. Now and the change in length is also maximized with respect to the its original length. If any body had its higher original length, so it maximizes with respect to its higher value. Okay. So this when we added both, so what we get? So here alpha, when we get you know that when you snatch the alpha from proportional terms, so it becomes is equals to constant. Okay, L1 delta T. So alpha delta T. What is alpha? Basically, alpha is the coefficient of linear expansion. Okay, it is the constant of proportionality, and this proportionality is called the coefficient of linear expansion. And how we can define it? We can define the coefficient of linear expansion with respect to its definition. What is its definition? Delta L. So the coefficient of linear expansion is the change in length. What is the delta call you? It is the change in length. The change in length per unit original length per degree rise in or change in temperature. Okay, its simple definition is the change in length per unit original length per degree change in temperature. This is the definition of alpha. Okay, now we will move on simple which is the third, cubicle thermal expansion. Same as it is, but the basic difference is volume wise. When you give heat to any cubicle body, so or just anybody, but so due to the increase in temperature, it expands volume wise. So this is called cubicle thermal expansion. Okay, so same procedure we will follow. You just give, if you give high temperature, means you just if initial temperature is T1 and if final temperature is T2, which is very high, so change in temperature is very high. When you give high change in temperature, so it expands cubically also very high. So delta V is also directly proportional to delta T is also directly proportional to delta V, which is equation 1. And same you will get its original value. Okay, if you have the original cubicle value is very high, then it boosts it at once due to its higher value of originality. So its change in volume is also become high. So when we add it, delta V is proportional to V1 delta T. Okay, we just write it oppositely, no issue. So here you know that when we snatch the value of proportion, so a constant will come, V1 delta T. So what will be happen? So B is the constant of proportionality, and this constant is called coefficient of cubicle expansion. Okay, what alpha is? Coefficient of linear expansion. And how we can define this? Basically, coefficient of thermal cubic expansion we will define same as it is with the help of expression. The change in length per unit original the change in volume per unit original volume per degree rising temperature is the cubical expansion. Okay, the change in volume per unit original volume per degree change in temperature, this is basically the beta. Okay, so you should know about that. What is the difference between what is the relation between cubicle and thermal expansion? Basically, we would like to discuss about the relation. Okay, and what is the relation? Beta is equal to 3 alpha, means coefficient of linear expansion is 3 times the coefficient of coefficient of cubical expansion is 3 times the coefficient of linear expansion. So what is this relation comes? How we can drive that? So simple. Let's suppose that is a cube. Okay, you have a cube. Let's drive it. Okay, that's a cube. Let's suppose in a cube, this is the length L. Okay, its original length L1, its original height is H1, and its breadth is B1. Original, just before giving to the heat. So, okay, so you know that about alpha. Okay, is a change in length per unit original length per degree rise in temperature. If we just reverse it, L1 alpha delta T is equal to delta L. You know that what is delta L? L2 minus L1. And simply when we just move on the alpha 1 on the left side, what will happen? It becomes positive. It's simple mathematics. We just take the common from this side. Alpha delta T plus 1 is equal to L2. And same as it is, the same value will be height. Okay, alpha delta T 1 H2 B1 alpha delta T 1 B2. That's bad. Okay, same, the both value will be remain same. Okay, so basically now we will move, or we just, this is equation 1. Let's suppose this is equation 2 and this is equation 3. We just multiply all the equations to each other. Multiply all equations. Okay, so when we multiply, one we get left L2 multiply H2 multiply B2. L1 alpha delta T plus 1. Okay, plus H1 alpha delta T plus 1. B1 alpha delta T plus 1. Okay, sorry, this will multiply it. Okay, multiplied. We both multiplied on both sides. So how would it happen? L1 multiplied by H1 multiplied by B1. We take it from this, and we take the common, especially alpha delta T plus 1. We take it these in a cube. Okay, it becomes a cube. So basically, the terms are multiplied, and alpha delta T plus 1 had 3 times. So are 3 times, so they becomes cube. Okay, so we know that. Okay, what we know here, L1 H1 B1 is the V1, and L1 L2 H2 multiplied by B2 is the V2. We know that length, breadth and height becomes the volume. So L1 B1 H1 is the original volume. L2 H2 B2 is the, after that, the volume of given the heat. So what it becomes? Okay, it becomes V1 alpha plus alpha delta T plus 1 whole cube is equal to, it becomes V2. Okay, now we expand with the help of formula, and we know that what is the formula of A plus B cube? A plus B cube. What is the formula? A cube plus, okay, do we just uh, 3AB means 3A square B plus 3AB square plus B cube. Okay, this is basically the formula of A plus B cube. So we expand with the same trend, alpha cube, alpha plus delta T cube. Okay, alpha delta T cube plus 3 alpha delta T square 1, okay, plus 3 1 square alpha delta T plus 1 cube, okay, is equals to V2. So here we just get it, the value, we know that, we just discuss about that. Alpha delta T value, cube value is very high. When we apply cube, it applies on both sides, alpha cube and delta T cube. And same in the happen in the term, the squares and we just ignore, because we know that the value of alpha is in points 0 0 0. When you take its square or its cube, or same in the delta situation, delta T is very points. So when you square and the cube, so its value almost, its value become negligible, 0. So we just neglect both terms. We just neglect the term this, and we just consider this. Okay, so V1 become 3 alpha delta T plus 1. Okay, so when we multiply that, V1 3 alpha delta T plus V1 is also V2. When we just V1, we will just go to V1 to the right side, it will become V2 minus V1, 3 alpha V1 delta T. So what it's become? It's become delta V, basically the change in volume, V1 delta T. When we just multiply and send it to the right side, it becomes divided by delta V. So okay, V1 delta T. So what it becomes? This is the value of B, beta. So it proves that 3 alpha is equals to beta. Okay. So basically, this is the relation between a linear of the thermal expansion on the linear wise and the thermal expansion with the volume wise. Okay. So with the help of this relation, we just prove beta is equals to 3 alpha. So thank you very much. We will hopefully come on the next in the next class with the next topic. Okay? Thank you very much.